Okay, so this is dimension analysis part B. Remember, it's really important that we focus on the process, not so much focused on the answer. So we're going to try a few problems here. First problem is, how many miles will a person run during a 10-kilometer race? Okay, so when we do the problem, we're going to do exactly like we were doing before, where we're going to have a given value. And that given value is 10 kilometers. And we have a target unit, and that target unit is miles. Okay, so we're going to draw a horizontal line, we're going to draw a vertical line, and we're going to take our given value and we're going to insert it into the starting point, 10 kilometers, just as you see here. And now we need our conversion factor. And in this case here, 1 mile is equivalent to or equal to 1.61 kilometers. So we have the 1 mile, 1.61 kilometers. We put that into the next section so that the kilometers will cancel. So the kilometers go in the denominator. That leaves us with miles. So now we just solve it. So we're going to take the 10 and we're going to multiply it by 1 over 1.61, which means we're basically saying 10 divided by 1.61. So that gives us 6.21. So the answer is 6.21 miles. A person running a 10-kilometer race will run 6.21 miles. Let's try another one. If it takes 730 milliliters of liquid gold to make a gold bar, what is the weight of the gold bar in pounds? Okay, so we're going to do a conversion factor here, or conversions for milliliters to pounds. Now the density of gold is 19.7 grams per milliliter. We need the density because we're going to convert from a volume unit to a mass unit. The given value in this problem is 730 milliliters. The target unit is pounds. Again, we're going from a volume to a weight, or mass, if you will. So, 730 milliliters will be our starting point, and will go right here on our dimension analysis bracket, and then we use our conversion factors. And as I said, since the density of gold is a conversion factor for us, the 19.7 grams per milliliters means that for every 19.7 grams, you have 1 milliliter, or 19.7 grams equals 1 milliliter. So we can use that to convert from milliliters to grams. 19.7 grams goes on top, 1 milliliter goes on the bottom. It allows us to cancel out the milliliters. Now, from the table of conversions that you have, 454 grams is 1 pound. So the 1 pound goes on top, the grams go on the bottom, 454. It allows us to cancel out the grams, and what we're left with is pounds, which is what we're trying to get to. So now we just have to solve it. To solve it, we multiply all the numbers across the top, 730 times 19.7 times 1, and we get 14,381. We multiply the numbers across the bottom, 1 times 454, and we get 454. So now we have a fraction, and we divide the fraction. 14,381 divided by 454 gives us 31.7. So it's 31.7 pounds for this gold bar. Let's try another one. The car is traveling at 65 miles per hour. How fast is the car traveling in feet per second? Now, miles per hour is a fractional starting unit, and feet per second is a fractional finishing unit, or target unit. So what we're going to do is, you're going to see, we're going to have to do multiple conversions where we're going to convert both the miles to feet and the hours to second. Our given value is 65 miles per hour. Our target unit, as stated above, is feet per second. So what we're going to do is we're going to draw our horizontal line, we're going to draw our vertical line, and we're going to take the 65 miles per hour and we put it into the dimension analysis bracket. And now we look at our conversion factors. Okay, and we're going to list these out. From your table of conversions, 1 mile is equal to 5,280 feet. We also know that 1 hour is equal to 60 minutes, and that 1 minute is equal to 60 seconds. Okay? Now we could choose to convert either one first. You could convert hours to seconds, or you can convert miles to feet. I'm going to do miles to feet. So I'm going to take the first conversion factor, 5,280 feet, and put it over 1 mile and cancel out the miles. This leaves us with feet, so we're halfway to converting to feet per second. And now what we're going to do is we're going to take the hour and convert that to seconds. So 1 hour is 60 minutes. That will cancel out the hour unit. And 1 minute is 60 seconds. I think I said 60 seconds. 1 hour is 60 minutes. Okay. And 1 minute is 60 seconds. Okay. So we're going to cancel out the minute value. And that will give us feet over seconds. So we go ahead and solve it. And you get 65 times 5,280 times 1 times 1. And that's 343,200. And 1 times 1 times 60 times 60, and that is 3,600. So now we have a fraction. We have our numerator value, and we have our denominator value, and now what we do is we just divide this, and we get 95.3. So the answer is 95.3 feet per second. A car going 65 miles per hour is traveling at 95.3 feet per second. So let's try another one here. Now this one here is going to have a cubic unit. You're going to see how that has to be handled using dimension analysis. A solid silver cube has a volume of 27.0 cubic inches. If the density is 9.32 grams per milliliter, what is the weight of the cube in pounds? So we got a cube here with 27.0 cubic inches. The given value is our volume, which is 27.0 cubic inches. The target unit is pounds. So this is similar to the problem we did with the gold bar, where we're converting from a volume to a weight value, or a mass value, if you will, even though technically they're not the same thing. 27.0 inches cubed is our starting point. And what we're going to do is we're going to look at our table of conversions. And if you look at the table of conversions, you'll see that 1 inch is equal to 2.54 centimeters. So we're going to use that to convert from inches to centimeters. Now, we need to do this 3 times. Since it's inches cubed, that means it's inches times inches times inches. So in order to cancel out the inches cubed, we need inches times inches times inches in the denominator. So 2.54 centimeters over 1 inch, 2.54 centimeters over 1 inch again. And what this allows us to do is to cancel out the inches cubed value, as you can see. So now we're in centimeters cubed, because centimeters times centimeters times centimeters is centimeters cubed. 1 centimeter cubed is 1 milliliter. A cubic centimeter is a milliliter. So what we're going to do is we're going to use that as a conversion factor, 1 milliliter over 1 centimeter cubed. The centimeters will cancel out with the centimeter cube, and that puts us into milliliters. Okay. So now what we need to do is we're in milliliters, but we want to get into pounds. So we got to use the density. Density allows us to convert from a volume unit to a mass unit. So the density of silver is 9.32 grams for every 1 milliliter. So 9.32 grams, 1 milliliter. The milliliters will cancel, and we're into grams. And one more step, just like in the gold bar problem, 454 grams is 1 pound. So we'll put the 454 grams on the bottom and the 1 pound on top. Remember, units have to be diagonal in order to cancel. And we're left with pounds as our target unit. So now what we need to do is we need to multiply all the numbers across the top and get a numerator value, and all the numbers across the bottom and get a denominator value. So multiplying across the top, 27.0 times 2.5 times 2.5 times 2.5 times 9.32 is 4,123.64. Multiplying the numbers across the bottom, we get 454. So we divide this and we get 9.08. So this cube weighs 9.08 pounds. So the silver cube will weigh 9.08 pounds. So now what I want you to do is I want you to go through and try to do part B of the dimension analysis homework. And you should be able to do all the problems on there given what we've seen.